Selection of samples. There are many different methods of sampling, and those below are really just a small number of them. Amongst them are, but before we leap into these, you really only need to know about the probability-based samples, which we'll get to a bit later. Opportunity sampling. The term is self-explanatory. A sample is chosen from those members of the population available at the time. This is also known as convenience sampling. So you just sample the people that you have access to at the moment. For example, if you're doing a survey about the school canteen, you might just go to the school canteen. Or sometimes you see this type of thing with surveys being done at supermarkets, for example. Quota sampling. This is a non-probability sampling technique wherein the assembled sample has the same proportions of individuals as the entire population with respect to known characteristics, traits, or focused phenomenon. This type of sampling is often seen at supermarkets when a new product is being tested. Yes, there's a certain amount of opportunity sampling involved with that, but with quota sampling, you get so many respondents under 20, so many from 20 to 30, etc. So in other words, the person conducting the survey is trying to fill a quota of different demographics. Judgment sampling. Instead of using probability, judgment is used in an attempt to select a representative sample. Propositive sampling. Choosing representatives that meet certain conditions. For example, you might only want to get people who have shoulder-length hair. This course, however, is mainly concerned with probability-based sampling techniques, such as the following. Simple random sampling. In this type of sampling, every individual has an equal chance of being chosen for the sample. This is often done using random numbers, as we will see in the examples that follow. But this is the classic. Everybody puts their name in a hat and we draw the names out of a hat. Stratified random sampling. Suppose we were doing a survey at your school. There may be issues on which opinions would be very different in different year groups or genders. A simple random sample can still end up with some ages or genders being disproportionately represented. And that means either we might have proportionately too many or too few. Even with a random sample, especially if the sample is of smaller size, we could end up, for example, with far too many boys from year 7. With a stratified sample, we split the groups. For example, making sure we get 10% of year 7 girls, 10% of year 8 boys, and so on. Performing a simple random sample within each group to give us our stratified sample. So, in other words, you split the groups up. So you might have year 7, year 8, year 9, and so on. And you've got boys and girls. And then within each section, you take your 10% sample. Cluster sampling. Choosing a group from the population to be the sample. The group is usually selected at random, but of course the way you construct those groups has to be done carefully, or you really will end up with problems of under or over representation. The last one that we're going to look at here is systematic sampling. The first representative is chosen at random, and then every nth individual is chosen. An example below explains this one well. For any probability-based sample, we will need to work with random numbers. These may be tables of random numbers or pseudo-random numbers generated on the CAS, or indeed on your scientific calculator.